I'm going to do a quick demo of the add and subtract instructions in the J8CM. I'll start over here on the right where I've got some assembly code and just kind of go through this. I've already compiled and loaded the code into the computer emulator, but I'll just go through the code real quick. We'll talk about that, um, and then we'll go ahead and put something in the input stream and run through it. Starting with memory location 10, I've reserved 10, 11, and 12 for data, and I've labeled them A, B, and C. Then down at memory location 20, I start the program, and the first thing I do is I input from the memory stream, or the IO stream, excuse me, and store it in memory location A. Then I'll go ahead and load what I just put in memory location A. I'll load that into the accumulator. Then I'll get the next byte of data from the IO input stream and store that in B. Then I will run. I'll execute the add instruction, and that will add that data that we just put into B. It will add that to the data that's in the accumulator. Then we'll store the accumulator in C, and then we'll output what's in C to the output stream in the IO panel. After we do that, I'll put 40 into the program counter, and then we'll input again from the IO stream. We'll store that in A. We'll load that into the accumulator, input B from the input stream into memory location B, and then we'll subtract that from what we've put in the accumulator, store it in C, and then write it to the output stream. So if I just come over and I go to the IO panel, and I have to put some numbers into the input stream for us to read. So if we just start with 8, so I'll set that bit, and the first thing we'll do is we'll load 8 into memory location A, and then we'll read that into the accumulator. And then the next data that we input will go into memory location B, and then we'll add that contents to the accumulator. So I've got 8 for my first byte of data, and then a 7 for my next byte of data. So the instruction will add those together, and then it'll write that output to the output stream, which is going to be 15. I'll also go ahead for our subtract demonstration. I'll just go ahead and set bit 6, which is a 64, and we'll just go ahead and subtract, well, let's subtract 4 from it, and that should give us an output of 60. So I can exit from here, go to the front panel, and in the program counter, I'll go ahead and put 20 in there, which is, let's see, 70, that's there, and there, that's 20. I go ahead and exit out, and then I'll go ahead and step through that. And the first thing it did was it loaded, it took that first byte of data from the input stream and it stored it into memory location 10. Next, I load that data then into the accumulator. Now I'm going to read the next piece of data, and I'm going to add that to the accumulator. And recall that was 7, so now we've got 15 in the accumulator. We'll store that out to memory location 12, and then we'll write that to the output stream, and that should bring us to a halt. And now I'll go ahead and load 40 into the program counter. Whoops, I wanted to do that. Let's load 40 into the program counter. And let's see, that must be 32, set that, and set that. Okay, so that's 40. Exit, and we'll step through that. Now we've just input then that 64 was the number that we've just stored into memory location 10. You can see that in the memory address register that we're storing into 10. Now we've loaded that into the accumulator, and you can see this bit is set, which is 64. Tells us it's the binary code for 64. Next, we input the whatever I put in there, 4, I guess, and that's now in memory location 8, and we'll go ahead and subtract that from the accumulator, and that gives us, well, let's see, 32 and 16 is 48, and another 8 is 56, and another 4, 60. Yeah, just like we figured. And then it'll bring us to a halt. I think it'll bring us to a halt. Oh, no, it won't. Yeah, it should. Yeah, sorry, it wrote that to the output stream. My mistake. Now it'll bring us to a halt. And I forgot that we were going to output that data. So now we'll go and look at our I/O stream. And you can see on the left here the I/O marker for the input stream has been moved. It's moved to 004, so it's input 4 bytes of data. And here's our output. We had 8 plus 7 gave us 15, and then 64 minus 4 gave us 60. And we can change this to base 10, and we can see that in something that's a little more readable. So 8 plus 7 gave us 15, 64 minus 4 gave us 60. And that's how the simple add and subtract, that was memory direct mode. I'll just keep this one short, and I hope you found it somewhat interesting. Thanks.